So the next process variable that we'll be looking at now is temperature. Temperature. Temperature is also a process parameter that could change with changing operational condition in our process. So what is temperature? Temperature actually is a measure of the molecular energy, okay, of the process material or process fluid that we are looking at. That is the heat energy that is contained in the process, or the potential of the process to transfer heat, or the process material to transfer heat. So this is one of the most, in fact, is the most measured variable in process industry. So we have basically 4 temperature scales. 2 of them are the most popular, that is the Fahrenheit and the Celsius scale. We also have the Kelvin scale and the Rankine scale. So this Celsius scale and the Fahrenheit scale, they are the most popular temperature scales in the process industry today. So in the Celsius scale, you see that the boiling point of water is 100 degrees Celsius, okay? And then the freezing point is 0. And that corresponds with 212 degree Fahrenheit for boiling point and 32 degree Fahrenheit for the melting point or freezing point of water. So this variable temperature, we have different sensors that we can use to monitor temperature, okay? So we have sensors that uses expansion fluid or expansion devices. An example is those fluid or materials when heated, they tend to expand. Then when they are cooled, they contract back to their normal state or normal position or structure, okay? So here are some examples of fluids or liquid that could expand when heated. We have mercury, we have alcohol, and we have pentane. So all of these, they are used in the mercury in glass thermometer. So this is the mercury in glass thermometer. As you can see, this is the bulb containing the mercury. So once you heat up this bulb or make it to come in contact with whatever temperature, whatever body that you want to measure the temperature, you see that it will absorb the heat and it will start rising through the stem, okay? So you see some calibration on the stem. So these calibrations, they've done to give us a direct reading of the amount of heat or temperature that can cause the rise of that mercury along the stem, okay? So this is one temperature sensor, which is a temperature thermometer. It's called thermometer, and this is the clinical type thermometer that is used mostly in the clinic for medical purposes. And this is what you have here. You have the expanding liquid, okay, or the liquid that is capable of expansion in the bulb. So once the bulb is heated, it will expand along the stem. So the height to which it gets to is calibrated to give us a direct reading or give us the temperature of the body that we are actually measuring, okay? So in some we have the alcohol and the others we have the pentane. So as you can see, they have different range of temperature for which they are very, very effective. So if you look at the mercury, is between 35 and 510. Okay, you can comfortably or conveniently use to measure temperature within those range. Then the alcohol -80 to +70, and then pentane -200 to +30. Okay, so you see that this kind of thermometer is fitting for cryogenic area or cryogenic process. Okay, so also is the alcohol to some extent. Why a process that is very hot, this could give us a more reliable reading, that is the mercury in glass thermometer. So we also have other types of sensors apart from those that uses expansive liquids that are capable of expanding. We have the one that uses expansion devices or materials that are capable of expanding as they are when heated as their sensor. Okay, so an example is the bimetallic strip or bimetal. So when you say bimetal, we are talking of two dissimilar metal that have different thermal conductivity joined together. Okay, so you see, as in this diagram, since they are separated, when you subject them to the same amount of heat, okay, delta T, you see that one is capable of elongating or extending more than the other. But once they are joined in the middle, okay, you see that it is no longer possible for the metal on top to extend more than the red, that is the red one now, to extend more than the blue. Okay, so that will cause a bending effect on the metal since they are bonded. Okay, so this is an example of what we are discussing. So this movement, this bending movement or this displacement correspond to a certain level of temperature rise of the bimetal. Okay, so this could be calibrated on the temperature scale to give us a direct reading of the temperature that causes that movement. So here we see an example of it. Okay, so you see, once it is subjected to heat, the sensor, which is the bimetal, it will expand. As it's expanding, it causes the movement of the pointer. Okay, and it can move either to the right as the temperature is increasing, and to the left as the temperature is decreasing, to give us a direct reading of the temperature that is causing that movement. So these are the example of the thermometer gauge, temperature gauges with the bimetal that is in this sensor or in this area that is attached directly, okay, into the process. So here I have a direct contact with our process. As it's heated up, the bimetal in it will elongate, and that will cause the movement of the temperature gauge. So let's assume that this one is in the process now. It shows here that the temperature of the process is about 20 degrees Celsius. So this is a form of sensor that could be used to look at the temperature in our process. Okay, so this is temperature